Welcome to another lesson about the art of programming with Python. In this lesson, we'll delve into the concepts of compilation, syntax, and semantics. These might sound a bit intimidating at first, but don't worry, we'll break them down step by step until they make perfect sense. A solid understanding of these terms is key to becoming a confident programmer. So I encourage you to watch the entire lesson. We'll also discuss bugs, what they are, and the different types every programmer encounters. Let's get started. In the previous lesson, we saw that a missing parenthesis results in an error. Why would a seemingly small thing like this prevent us from running the program? Understanding this will give you the right mindset for the most technical level of programming. Python is a high-level programming language, which means that it is designed to be easily read by human beings. The computer does not natively understand Python, or for that matter, any human-readable programming language. Therefore, a program needs to be translated into a form suitable for execution. This process of translation is called compilation, and a tool that performs it is called a compiler. For some languages, the code is compiled down to a low-level language called the assembly, which is then easily translated to machine code. Machine code consists of instructions written in zeros and ones that can be directly executed by the CPU, the brain of the computer. For Python and some other languages, the code is not compiled all the way into machine code. Instead, it is translated into an intermediate form called bytecode, which is run by a special program called a virtual machine. To get your program to compile, you need to follow the rules of the language, known as its syntax. As we've seen, the compiler is strict and won't let even the smallest syntax error slide. But here's the deal. If you stick to the syntax, the compiler guarantees that the compiled code it generates will behave exactly as defined by the part of the language specification called the language semantics. When our program does not follow the rules of the language syntax, we get a syntax error. In this case, the compiler flags the error, and we can't run the program until it's fixed. Note that the actual problem in this example is the missing parenthesis right here. But the compiler can't know that. Instead, it detects that the leftmost parenthesis is never closed. And that is the syntax error it reports. If the program compiles and runs but does not behave the way we expect, that's a logic error. Novice programmers often struggle with syntax errors, and that's normal. But over time, you'll find that syntax errors are usually pretty easy to fix. Logic errors, on the other hand, can be incredibly tricky to track down and resolve. Programmers often refer to logic errors in a program as bugs, though this term is sometimes used informally for syntax errors too. The process of fixing bugs is called debugging, and a tool that helps locate errors in a program during runtime is called a debugger. That said, for simpler issues, a debugger can be overkill, and we will learn simple techniques that are more effective in those cases. Here are the many terms you've learned in this lesson. To summarize, Whenever you run a program, compilation must take place first. If the program doesn't follow the language's rules, the compiler will report a syntax error and the program won't run. Fortunately, syntax errors are usually straightforward to fix. If the program compiles successfully, it will run. At that point, it will either reveal a logic error that requires debugging or behave as expected. This course helps you increase the chances that your programs will run as expected. Thank you for choosing to learn with me, and I look forward to seeing you in the next lesson.